Welcome to Mastering Solutions. In this question, a picture will not only give us the ray diagram for the question, but it also really helps a lot to see what's happening. So if this is the edge of our mask, and we'll say over here is the water, so this is going to be the 1.33. And then in here is where the air bubble is trapped, so that'll be n of 1. And then they tell us that there's a fish that we're looking at, right? Okay, so here is our picture of the fish. This question really helps us to understand how a change in index of refraction changes where an image is going to be. And so light reflects off of everything, and that's why we're able to see things, right? The book talked about that. So light is coming off of the fish here, and we're going to say that it goes like this. So we're just going to show two rays just to illustrate the point. And then as it hits the glass here, we're not going to worry about the glass. We're just going to assume the 1 and the 1.33. If we said this is a normal right here, and then there's another normal right here, when we go from a higher to a lower index of refraction, what happens? The light is going to be refracted and it's going to bend away from the normal. So I'm exaggerating it a lot so that we can really see the point. So it'll be away from the normal. And again, exaggerated so you can get the point here. So for us, we're looking from the mask here, right? So this is our eye. And to us, what we see is these light rays after they're refracted. And so if we extrapolate it back, to us, when we're looking from the index of refraction of 1 into here, it's going to appear to us that the fish is actually closer than it actually is. The fish is back here, right? This is where the image will look to us. If we do the same thing, only in this time to the fish, it's going to look at our eye. So as it looks at our eye here, we're going to have light coming off of our eye as well. And so we'll do the same thing. Let's just draw two lines to represent the change. And so here's going to be our normal, and the fish is over here. We'll just put a little dot to represent the fish this time. So now we're going from a low to a high index of refraction. So what is happening in this case? Well, the light is going to refract towards the normal. So it's going to come closer. So it's going to come further in. I didn't exaggerate it as much, but you can see how it's bending in towards the fish more. So as that light to the fish gets extrapolated back, well, it's going to be back here. And so to the fish, our eye is going to seem as if it's back here. So it's further away. And so the question is doing, like I said, is it's really illustrating the differences in an index of refraction and how that changes with the refraction and the perceived image that we see. To the fish, because of the high to low index of refraction change, it'll look further. But to us, for the low to high index of refraction change, the fish will look closer.